Isotonic regression assumes that the relationship between your input and output is always increasing or always decreasing. That's the monotonic part. If the real relationship isn't like that, maybe it goes up, then down, then up again, isotonic regression will struggle to fit it well. This mismatch leads to poor performance on new data. Your model learned the training data too well. It memorized the quirks and noise instead of focusing on the main patterns. That's why it does great on the data it already saw but bombs on new, unseen data. It's like cramming for a test instead of truly learning the material. Think of your training and test data as coming from different sources. Your model is a skilled chef, but you've only taught it to make Italian food based on your training data. If you test it with French food test data, it will likely perform poorly. The model isn't accustomed to the new ingredients data. I see a big problem here. The model works great on the data it's already seen, training data, but fails miserably on new, unseen data, test data. This screams overfitting. It's like a student who memorizes the textbook perfectly but can't apply the knowledge to new problems. The model learned the training data too well, including the noise or random variations, instead of the underlying patterns. Isotonic regression assumes a monotonic relationship, either always increasing or always decreasing. But what if the real relationship isn't like that? Imagine a graph that goes up, then down. Isotonic regression can't handle that, so it will fail to generalize well to data where that non-monotonic pattern appears. Think of it this way: I trained my model on pictures of cats, but tested it on pictures of dogs. Of course it will fail. If the test data comes from a completely different source or has different characteristics than the training data, I'll get bad results. As I mentioned before, the huge difference between how well the model works on training data versus test data is a classic sign of overfitting. The model is memorizing the training data rather than learning the underlying patterns. It's too closely tied to the specific quirks of that training data to generalize effectively. This is a bit of a trick question. Regularization helps prevent overfitting, but isotonic regression in scikit-learn doesn't have a regularization parameter, like some other models, so you can't just tweak a knob to fix this. I'm evaluating how well my isotonic regression model is doing. Isotonic regression is a type of model that assumes a relationship between variables either always goes up or always goes down. The evaluation is showing a problem. It's doing great on the data it was trained on, but poorly on new data. I'm evaluating how well an isotonic regression model performs. This involves looking at how accurately the model predicts on both the training data used to build the model, and unseen test data, new data the model hasn't seen before. This is the data set I use to teach my isotonic regression model the relationship between features and target variables. The model learns from this data. This is a specific type of model. It assumes a monotonic relationship, meaning a consistently increasing or decreasing relationship between the inputs and outputs. This is a completely separate data set, used to evaluate how well my trained model generalizes to unseen data. It's how I test if my model has truly learned the underlying pattern, and isn't just memorizing the training data. When I test my isotonic regression model on the training data, the error is low. This means the model fits the training data very well. However, when I test my model on the new test data, the error is high. This suggests my model hasn't learned the underlying relationship well enough, and is likely overfitting. This means my model is too closely tied to the training data. It's memorizing the specific details instead of learning the general pattern. This leads to poor performance on new, unseen data. My isotonic regression model assumes a monotonic relationship, always increasing or always decreasing. If the true relationship in my data isn't monotonic, the model won't be able to capture it accurately, and will struggle to predict well on new data. Isotonic regression, as implemented in scikit-learn, doesn't use regularization parameters. Regularization is a technique used in other models to prevent overfitting. Therefore, this isn't a cause for this specific issue. The test data might be fundamentally different from the training data. If the underlying patterns or characteristics are different, it's expected that the model trained on the training data would not perform well on the test data. This is a common cause of poor model generalization. I'm looking at the data used to train the isotonic regression model. This is where the model learns the relationship between features and the target variable. A low error on this data suggests the model fits it very well. I'm checking how well the model generalizes to new, unseen data. This data was not used to train the model. A high error here suggests the model doesn't perform as well on data it hasn't seen before. I'm using a specific type of regression model, isotonic regression, that assumes a monotonic relationship between the input and output. That means the relationship is always increasing or always decreasing. The isotonic regression model fits the training data exceptionally well, resulting in a very low error. This sounds great, but it's potentially a warning sign. However, when I apply the model to new test data, the error is significantly higher. This is a big red flag. It shows that the model's performance is not generalizing well to unseen data. This is a likely explanation. The model learned the training data too well, including noise and quirks that aren't representative of the true underlying pattern. It's like memorizing the answers to a test instead of understanding the concepts. The true relationship between the features and the target might not be strictly increasing or decreasing as the isotonic regression model assumes. If that's the case, the model will struggle to generalize. It's like trying to fit a straight line to data with a curve. The test data might come from a different distribution than the training data. This is a common problem in machine learning. It's like training a model on images of cats and testing it on images of dogs. They're different. I'm asking you to identify the reasons why a machine learning model is performing really well on the data it was trained on, but terribly on new, unseen data. This is a common problem in machine learning. Let's break this down. You're using a specific type of model called isotonic regression from a library called Sklearn. It's working great on the data it has seen, the training data, but bombs when it sees new data, test data. This difference is a major red flag. This is a strong possibility. Overfitting means the model has learned the training data too well, including all the noise and quirks. It can't generalize to different data. Think of it like memorizing the answers to a test instead of understanding the concepts. Isotonic regression assumes a simple relationship, either constantly increasing or constantly decreasing. If the real relationship in your data is more complex, maybe it goes up, then down, then the model will struggle to capture it properly. This is tricky. Regularization is a technique to prevent overfitting, but the basic isotonic regression in Sklearn doesn't have this feature. It's a distractor to see if you really understand the model. Your test data might be different from the training data in some important ways. If so, the model, having learned patterns in the training data, won't do well on the test data. It's like training a model on images of cats, but then testing it on dogs. Not a fair comparison. This is the data used to teach the isotonic regression model. The model learns the relationship between features and target variable from this data. This is new, unseen data used to evaluate how well the trained model generalizes. Good performance here indicates the model is learning the underlying patterns, not just memorizing the training data. This is the specific type of model being used, one that assumes a monotonic, always increasing or always decreasing, relationship between the input and output. The model is performing extremely well on the training data. This could be a good thing, or a very bad thing. The model is performing poorly on the new data, indicating a problem with generalization. This is often a sign of overfitting. I'm evaluating how well an isotonic regression model performs. This involves checking how accurately the model predicts on both the data it was trained on, training data, and new data it's never seen before, test data. The goal is to build a model that generalizes well, performing well on both. Overfitting happens when a model learns the training data too well, including noise and random variations. This results in excellent performance on the training data, but poor performance on new, unseen data. It's like memorizing the answers to a test instead of understanding the concepts. Isotonic regression assumes a monotonic relationship. That is, the relationship between the input and output consistently increases or decreases. If the real relationship isn't monotonic, e.g., it goes up then down, the isotonic regression model won't fit well, leading to poor generalization. It's like trying to fit a straight line to a curvy path. Regularization is a technique to prevent overfitting in many machine learning models. It adds a penalty for overly complex models. However, scikit-learn's basic isotonic regression doesn't have a built-in regularization parameter. So, this isn't relevant here. If the test data is significantly different from the training data, then the model's performance on the test data won't be a good reflection of how it will perform in the real world. It's like training a model on summer weather data and testing it on winter weather data. The results may be very different.